Welcome back. This is Mr. Hassan's Maths channel, and I'm answering a question here from the February-March 2022 paper. This is question number 12, part B. I'm doing that as a separate question because this is a separate topic really from part A. So this is question 12, part B from this paper. Now, it tells us to sketch the curve y equals x cubed minus 4x. Now, sketching curves is something that's relatively, I wouldn't say it's new, but the focus has kind of like increased on it in this new syllabus, basically. So I've noticed a lot of questions coming up now, asking you to sketch curves. They could be quadratic curves, or functions in general could be like straight line graphs, could be cubic curves like this one, reciprocal curves, even exponential curves. So we have to have an idea of what these different shapes look like and how to recognize those. So if you see something that's like, for example, in the form y equals mx plus c, where you have the x with just a power of 1, right? You don't have x squared, x cubed, and it's in the numerator. For example, y equals 3x plus 2. Then you should know this is going to be a straight line graph. And to draw that, we can, to sketch that, we can find the place where it crosses the x-axis and the y-axis, and then just, sketch it that way. Or we could substitute, for example, we could say that the gradient is 3 and the y-intercept is 2. So it goes through 2 on the y-axis, and then it has a gradient of 3. So it's going to be something that looks like this. A straight line, of course, with a ruler. And you can find the place where it crosses the y-axis by putting y equals 0. And you can, mark those points and draw it with a straight line. That would be how you deal with a linear function in that form. If you have a graph, if you have an equation which has something like y equals, say, x squared as the highest power. So, for example, y equals x squared plus, let's say, 7x plus 12, something like that. Then you would sketch this by knowing that this is a quadratic. How do we know it's a quadratic? Because the highest power of x is 2, power of 2. And there's no x in the denominator. So this will have either a smiley face like this, if the coefficient of x squared is positive. If the coefficient of x squared was negative, then it would have a frowny face like this. It would have a turning point, and you'd have to try to find where it crosses the x-axis and the y-axis by substituting x equals 0 and y equals 0 into it to find the places where it crosses it, and so on. Okay, sometimes this type of curve turns before it touches the x-axis, in which case you'd have to find the vertex by completing the square. That's one way you could find it, and so on. So that's how we do with quadratics. You'll find them in the playlists at the end of the topic. You'll see a playlist of those type of curve sketching graphs. All right, so you can have a look there later on. Now, this is a cubic curve. How do we know it's a cubic curve? Well, because the highest power is 3 and there's no x in the denominator. Now, a cubic curve either has this type of shape, in general, it could differ from that, but in general it has this type of shape, or it has this type of shape. Okay, I call this one, it's like up, down, up, and this is down, up, down. Now, if the coefficient of x cubed is positive, it will have this type of shape. If it's negative, it will have that type of shape. So I know that this curve definitely will look something like this. It will have this shape here. Okay, because it's positive x cubed. So it's going to have that type of shape. All right, now, that's one thing. So we've got the general shape of it. It's going to look like that. So that's the first thing we determine. It's going to have this type of shape. When we draw it, it'll be something like that. Now we've got to find the places where it crosses the axes. So what we can do is we can say, all right, it crosses the y-axis when x equals 0. Okay, because this is the line, the y-axis is the line x equals 0. So when x equals 0, you've got y equals 0 cubed minus 4 times 0, which of course is 0. So it crosses the y-axis at the origin. Okay, and the x-axis is the line where y equals 0. So on the x-axis, the y value is always 0. So if we substitute y equals 0 into this equation, so we replace the y with 0, you have x cubed minus 4x equals 0. We've got to solve this equation, but we can solve it by factorizing, so we can take x as common. So you have x times x squared minus 4 equals 0. So we have either x equals 0, which is one of the places which we already know because it goes with origin, or we have x squared minus 4 equals 0. Now that can be factorized further. You can write this as x plus 2 times x minus 2, so difference of squares. So that means x equals negative 2, because x plus 2 is 0, or x equals positive 2. We could have also solved this by saying x squared equals 4, so x equals the square root of 4, but don't forget the positive and negative square root of 4, so x is going to be plus or minus 2. So in any case, we get x equals 0, x equals minus 2, and x equals plus 2. So I know this curve crosses the x-axis at these points. So it passes through the x-axis at x equals minus 2, and x equals 0, and x equals 2, and it has this shape. So it's going to be kind of like symmetrical. So I'm not going to mark where 2 is. I'm not going to put the points where it's passing through right now. I'm going to first draw my cubic curve. Even I prefer to not have the axis here and just to draw a cubic curve and then draw the axis afterwards, but it's already here, so we have to deal with that. So what I'm going to do here, I'm going to show you how to deal with sketching this curve. Basically what I'm going to do, I'm just going to do my best with the tools that I have here to draw a cubic curve of a good shape, but it has to pass through the origin. So it has to go up, then through the origin, and then up again. Up, down, up. That type of shape. So that's like minus 2. It's going to pass through the origin. Then it's going to go up. It's going to kind of be symmetrical. Now that last part is a bit off. It shouldn't turn back up on it. It shouldn't turn outwards, nor should it turn back up on itself, like go inwards. Something like that is fine. That's a pretty decent curve. It's not that good. I mean, it should be symmetrical because this is minus 2, this is 0, and this is 2. It's not bad. It's just a sketch. It's not meant to be perfect. Okay, it's a sketch. All right, so there is how you sketch this cubic function. Okay, that's how you sketch a cubic function. So that's the answer to part B. So I just gave a little summary of different types of curves. And different types of functions you might find. You might even find reciprocal functions like 1 over x, where x is in the denominator, which has asymptotes, which I've also gone to in some of the other videos I've made, which you will see at the end. Somewhere over here I'll have a playlist about sketching curves. Okay, so that I guess concludes this question. Other questions from this paper, when I complete them, will be in the playlist that will appear in this area over here. This is February-March 2022, paper 4, variant 2, from the IGCSE 0580 syllabus. Other questions about graphs of functions can be found in this playlist, and I'm going to make a playlist for just dealing with sketching curves, which I will place over here. And you can subscribe to my channel by clicking on this link. Thank you for watching. See you soon.